Welcome to BKW Physics. I'm Mr. McConley, and today we have a demonstration that is an energy demonstration. We're going to allow these two identical steel spheres to roll down different ramps. We'll do it like a race. That's why I got two of them. So, which two would you like to race? Now, the first track is actually blue, yellow, green, red. Blue, yellow, green, red. Which two would you like to race together to start?
Blue.
Blue and yellow. It is. So we take the first two. On your marks, get set, go. Track one, blue is the winner. So, yellow's out. Blue, who do you want to race now?
Red.
Green.
Red.
Green.
So the two outsides. The outsides. So, on your mark, get set, go. Oh, big winner. Big winner, blue. Red's out, yellow's out. We're only left with blue and green. We race those. Okay. So, we can see that blue is by far the winner. It beat everybody. The only one that was even close, really, was yellow. The other two were much slower. I want you to think a little bit more detail about this. Do these things start with the same potential energy up here?
Yeah.
Yes. Same height, same mass, same potential energy. Do they end with the same potential energy down here? Yes. Same height, same mass. Okay. Well, then think of the kinetic energy part of it. What kinetic energy do they have right here? None, because there's no velocity. We let them go. Can you see on the table that they're traveling at the same speed? Watch again if you didn't see it. Check it out. Notice that when they get to the table, the one is not catching the other one. They're going at the same speed. So what's true about their kinetic energies down here? Same. So they got the same energy here and the same energy here for both of our energies that we're checking. How can they not get there at the same time? That's what I want you to think about. So what is it that's happening to this that's making it so that they start the same, but somehow one of them gets there quicker, and it's apparently the one right here that gets there the quickest. And these ones are progressively slower, I guess. Well, actually, I think it went... I can't remember. Try these two. Yeah, it is. Okay, so... Alright. So, what's going on here? Yeah.
Blue, its kinetic energies increase at a faster rate than the yellow, but stop at the same speed yellow.
They're all starting equally. In fact, this first part of the ramp is the same for all of them, the first inch or so. But when the blue one hits here, this student's idea is that the velocity part of it, the kinetic energy, starts changing faster, which is true. In other words, it starts accelerating sooner. Because do they all get to the same speed at the end?
Yeah.
Yes. But this one gets accelerated here, while this one gets accelerated from here to here. See how that's a much longer distance? They're giving it more time to accelerate. It's still going to get to the same point, but this is a lower number. And this one actually doesn't really even start accelerating until out here. And then this one really only accelerates right at the end. In the end, they change from their initial speed to the same final speed, but this one, it happens sooner, or the process starts sooner. Therefore, it reaches its highest velocity. Let's say its highest velocity is 10. Where does this one reach its highest velocity? Probably right about there. Where does this one reach its highest velocity? Way down here. Highest velocity here. Highest velocity here. Does that make sense, everyone? So my only last question is, if this one right here, the third one over, the green, if that reaches its highest velocity sooner than the yellow one, how does it not beat the yellow one?
The yellow one's accelerating quicker, or it starts accelerating before that.
Yeah, look it up at the top. If you look up at the top, the yellow one starts accelerating right here. That's where the track is bent. The green one doesn't start accelerating to here. So the yellow one gets a slight jump start. Even though it's a lesser grade, it gets a jump start. That gets it ahead just enough that it stays ahead at the end. So for today, physics.